This will be Geometry Lesson 4, Chapter 4, Section 7. Today we're going to discuss the triangle inequality. We've been working with triangles all chapter long, and we're going to look at some shapes that might not make a triangle. So we're going to look at the triangle inequality, and we're going to look at the sum. I have a triangle right here. This is a right triangle that we've actually dealt with this chapter before. And what I want you to do is kind of compare the sum of any two sides of this right triangle. Meaning when I look at 9 and 12 and look at that sum. Or maybe when I take 9 and 15. Or maybe when I take 15 and 9. What you will see that the sum of any two sides of a right triangle, meaning if I take 9 plus 12. Now this is not Pythagorean theorem today. We will do a little bit of Pythagorean theorem, but when I take 9 plus 12, those two side lengths has to be greater than the third side of 15. Or if I go 9 plus 15, those two sides are greater than that 12. Okay, and obviously if I take 12 plus 15, that is going to be greater than 9. So what ends up happening here is that in order to form a triangle, if we have three side lengths, in order to form a triangle, the sum of any two of the sides must be greater than the third side. Meaning, if we look at this, this is, to put it simple, to make a triangle, the sum of the two shortest sides must be greater than the third side. So what we're looking at here, let's say I have the side lengths of 3, 4, and 6. Can I make a triangle out of a side 3, a side 4, and a side 6? Well, if we take the two shortest sides, 3 and 4, and I take 3 plus 4, is that greater than the third side of 6? Well, is 7 greater than 6? Yes. So can I form a triangle out of those three sides? Yes, I can. Well, some of you may be thinking right now, well, can't you form a triangle out of any three sides? Let's say I have a really long side like this. Okay, now let's say I have a really short side. And then I come over here and I may have another really short side. And let's put some measurements on here. Let's just say that this is 8 inches, and this guy right here is 2 inches, and this guy right here is 3 inches. Well, is that going to make a triangle? Well, no, it wouldn't, because if I continue with this side and I go ahead all the way down here and I lay it flat on top of there, well, I've only got 3 inches here, and I do the same thing over here. I can't make a triangle out of there, because what's going to end up happening is going to be like a drawbridge that kind of comes up short. I can't form a triangle out of these three side lengths because 2 plus 3 is not greater than 8. So I can't form a triangle out of these. What I could form, I could connect that and have a quadrilateral, but I cannot form a triangle. Right? So that's the triangle sum theorem and what it shows us. Now, if we look at this, if we have sides of 2, 3, and 4, now if you were in class, I'd have my straws out and I'd be showing you this. I have a side of 2 inches, 3 inches, and 4 inches. Can we make a triangle out of that? Well, let's take our two shortest sides, 2, 3. Take the sum of those. Is that greater than the third side of 4? Well, yes, it is, because 5 is greater than 4. So yes, we could form a triangle out of that. Alright, well, let's go to 2, 4, and 6. So if we look at 2, 4, and 6, we would take 2 plus 4. Is that greater than 6? Well, if you think it's 2 plus 4, that's 6. Is 6 greater than 6? No, it is not. So can we form a triangle out of these three sides? No, we could not. Well, let's go back to my example here. If we look at these, now I said 2, 4, and 6. So let's see what happens if we have a 4 and a 6. Well, what I would do is this guy would come all the way down here. It would lay flat. This guy would come here and it would lay flat with these guys. And they would very, very slightly touch, but what would happen is they'd be laying flat on top of that 6-inch side anyway. So can we form a triangle out of sides that are 2, 4, and 6? No, we cannot. Okay, so that would be a no, because they're going to be right on top of each other. It'd be like a drawbridge going down that just hits. Now 1, 2, and 3, can we take sides of 1 inch, 2 inch, 3 inch, 1 foot, 2 foot, 3 foot, and make a triangle? Well, if we go 1 plus 2, is that greater than 3? Is 3 greater than 3? No, it's not. So can we form a triangle? No. Alright, now let's look at 2, 3, and 6. If you take 2 plus 3, Is that greater than 6? No, 5 is not greater than 6, so that would be a no. We cannot. Right? So let's continue on, look at some more sides here. Now let's look, do the three sides form a triangle? Now this one should be obvious. Okay, we've seen this one, and this is one I told you, hey, remember this one. Do the three sides form a triangle? Well, let's double check. Take my two shortest sides, 3 and 4. 3 plus 4, is that greater than 5? Well, 7, okay, 7, is that greater than 5? Yes, it is. So can we form a triangle? Yes, okay. This is what we're doing this class. Do the three sides form a triangle? Yes. Why? Right here. That is our why. Our work is our explanation. Now, I kind of forgot to mention this. What you can be doing right now is you can be following along and watching this video and doing this work on the back of the lesson 347 worksheet. Okay, it should be blank. You can do the work on the back, take notes on the back. The front side will be your homework. Now, what we can do is we can extend this a little bit further. Yes, it makes a triangle. Let's go back to last class and say, what kind? What kind of triangle does this form? Now, this is what we did last class. To classify, we're going to have to use the Pythagorean theorem. Right? Now, you may not be doing this on every problem, but we could if we wanted to. So, yes, it makes a triangle. Then we could go, all right, 3 squared plus 4 squared. Let's compare that to 5 squared. This is what we did last class. So, this is 25. That's 25. They're equal. So, what kind of triangle do we have? Well, we have a right triangle. Okay. So, we did two things right there. Does it form a triangle? Simple. Just add. And then what kind? Well, what kind is where we do the Pythagorean theorem, the good old Pythagorean theorem, and figure that out. All right. So let's go to the next one. Do the three sides form a triangle? Okay, so do they form a triangle? We're just going to simply take the two smaller sides. We're going to take 7 plus 9. Is that greater than 11? Well, is 16 greater than 11? Yes. Okay, so here's our answer. Do they form a triangle? Yes. Why? There we go. Now this tells us, do they form a triangle? But again, what we could also do is what type. We could classify this, and that's very easy to do. That's what we did last class. To do that, that would be my hypotenuse. If it is a right triangle, we go 7 squared plus 9 squared. Compare that to 11 squared. That's 121. That's 81 and 49. That's 9130. Compare those. Okay, so here my a squared plus my b squared is greater than, so this would form an acute triangle. If you remember that little chart, I would keep it handy today because I'm going to make you do both of these things today. So this is, does it form a triangle? And this is what type of triangle? Okay, so two things we can do with these numbers. All right, let's go to the next one. Do the three sides form a triangle? So 5, 8, 13, do they form a triangle? Let's check. To see if they form a triangle, we take the two shortest sides, 5 plus 8. Is that greater than 13? Is 13 greater than 13? No, it's not. Do they form a triangle? No. Okay. Well, now we can go to classify this. So to classify this, we'd go 5 squared plus 8 squared, compare that to 13 squared. But wait, do we even have to do this? No, we do not. It does not form a triangle, so can we classify as a type of triangle? No, we can't. This would be that situation that we talked about earlier where this is 13. If I measure 5 this way, I'm right here. If I measure 8 this way, I'm right there still, so they're going to lay right on top of that 13, and they can't form a triangle because we don't have enough length with 5 and 8 to make any angle right up here. Right? Let's go to the next problem. 2, 6, and 9. Do they form a triangle? So let's go 2 plus 6. Is that greater than 9? Is 8 greater than 9? No. So the answer is no. Okay. So do these form a triangle? No, they do not. 2 plus 6 is not greater than 9, so we cannot form a triangle out of these. So can we classify this as acute, right, or no, we don't have to because it doesn't even make a triangle. Right? Next one, 5, 5, and 10. So if we look at 5, 5, and 10, is 5 plus 5, is that greater than 10? Is 10 greater than 10? No, it's not greater than, so we just slash it. We would say no. Now we have two equal sides, so what kind of triangle is this? It's not isosceles. It's not even a triangle, so we can't classify it as isosceles or acute or whatever. Right? So that's not a triangle. Right? 1, 2, 3. Do these form a triangle? 1 plus 2, is that greater than 3? Is 3 greater than 3? Nope. And again, this is the work I want to see because this is your y right here. Your answer is, do the three sides form a triangle? No. But why? There's your y. Just that little bit of work right there to show why. Right? Next one, 10, 20, and 25. So again, do they form a triangle? 10 plus 20, is that greater than 25? Is 30 greater than 25? Yes, it is. So do these form a triangle? Yes. Now again, we need to make sure that we follow directions. That's your y. This is your answer. Do they form a triangle? Yes. That's your y. Remember, we could go one step further and we could say, alright, classify. That's where we do the Pythagorean theorem. And we would go, alright, 10 squared plus 20 squared. Compare that to, remember we leave that blank, 25 squared, so that would be 100, 400, that would be 500. That's 625, and that is less than. So when a squared plus b squared is less than c squared, that becomes an obtuse triangle. Okay, so two things we can do. Does it form a triangle? What kind of triangle? Alright, so 2, 3, and 3. Now if we look at this guy, do the three sides form a triangle? 2 plus 3, is that greater than 3? Is 5 greater than 3? You betcha. So is that a triangle? Yes. Now classify it. This one's cool because if you look at it, we have two equal sides, so right away we know it's isosceles. But if we want to classify it by angles, we have to go 2 squared plus 3 squared. Compare that to 3 squared. That's 9 and 4. That's 13. That's 9. 13 is greater than 9. So if our a squared plus our b squared is greater than 9, this guy is going to be acute. So this triangle ends up being acute isosceles, and we could tell it was isosceles just by looking at two equal sides. The rest of these no equal sides are all scalene and then whatever. Right? So that's it for the triangle inequality. The sum of any two sides of a triangle needs to be greater than the third side. And we normally just start with the two shortest sides and then go. We also threw in sum of 4, 5, which is classifying using the Pythagorean theorem. So your homework today is to do lesson 4.7a. Okay, that's yours. Now follow the directions, please. You also have a review, which is Math Excel 4.7. Now, it's got review of pretty much the whole chapter. So next class, this is the last section in the chapter. Next class, we will do our chapter review. And then the following class, we will have our chapter test. So good luck. If you do have any questions, make sure you come and see me.